In question letter E, this is really where the important part comes in. We really want to ask ourselves, okay, which of these options is going to be the best? If the bank is going to give me free money, how can I get the most free money possible? So what we want to do is compare all four options over the course of 10 years and to see which account will give us the most money. In case you're wondering how to do that, I'll just point out that for each of these equations, we have a really wonderful built-in advantage. And that's that the letter X represents how much time we need our equation to count for. So if I want 10 years, X can be the amount of time the bank is going to kick us those payments, or the number of payments the bank will kick us over that 10-year span. So for option number 1, and I'll start with that one, let's think about what 10 years is going to look like. For option 1, and I'm just going to label this really clearly so that way I can see it, that means we have our 1,000, that was initial, times 1.12 to the power of, X is going to be 10 years, that's 10 annual payments. Now that's not something that I expect you to do in your head because 10 is obviously a big exponent. So a calculator will be very helpful here. Any sort of calculator will do. A graphing calculator is great if you have one, but it's definitely not necessary. Any calculator that has an exponent button will do the trick. And we would type 1,000 times 1.12 to the power of 10. That number is the dollar value of the account. So that means that in option 1, my account after 10 years will be worth $3,105 and about 85 cents. Now it's impossible to call this decimal like a real number of dollars and cents until you round it. So I always recommend rounding to 2 decimal places so it really looks like money. Now we can do that for all of the options to compare them and see which one is the best. This obviously looks like a great deal. I put $1,000 in the bank and now I'm up to $3,100 in the bank. I've like tripled my money and that sounds like a pretty sweet deal. That's the nice thing about investments. If you're patient and you just let that money sit there untouched for 10 years, you really can go back into your account later on and see more money there, having done nothing other than sit and patiently wait and not touch your money. Again, this is not the most realistic scenario yet. 12% is a little bit high for a normal bank account, but once you know how to do it with these kind of nice numbers, you'll be able to do it for even weird banking numbers too. Let's look at option 2 though, because here's the thing we need to remember about option 2. Option 2 was going to be twice a year. Remember that? They were giving us 2 smaller 6% payments instead of one big lump 12% payment every year. That means that my equation is 1,000 times 1.06, but I need to remember something. The X represents how many times they're going to give me my money. And if I'm thinking about 10 years, they're not going to give me 10 payments. They're giving me 2 smaller payments a year. So in terms of time, that's actually 20 payments because they're going to give me 2 payments a year for 10 years. That's 20 payments total. And that needs to be my exponent because the exponent needs to represent how many payments they are making. In the first one, the number of years was the number of payments because they weren't dividing it up into smaller pieces. But once we're dividing it up into smaller pieces, we have to be kind of careful. And that's why on the answer key, you'll actually see I snuck a little 2 in there next to the X. And that's to remind me that I'm actually getting 2 payments per year. 10 years times 2 payments per year is where the 20 comes from. So in any case, that's what I'm calculating. 1,000 times 1.06 to the power of 20 payments, and I'll get my account value of $3,207 and about 14 cents. Again, good deal because my money sat there and I noticed I even earned a little bit more than I did in option 1. So this is even better because now I've gotten more money just for letting my money sit there and do nothing. So option 3, same idea. We just have to pay close attention to how many payments we have, because that's the only kicker about that X thing, is recognizing how many payments were there. Option 3 was the quarterly thing. So that's 4 payments per year. You can sneak a little 4 into your exponent as a reminder, because 10 years worth of time, 4 payments per year, that's going to be 40 payments total. So that means my equation is going to be $1,000 times 1.03 to the power of 40 payments. And again, I'll calculate that. 1,000, 1.03 to the power of 40 payments. That's $3,262.04. Again, that's better than we had before. So every time I'm doing this, it seems like it's getting better and better. That's good news. So let's assume option 4 might be the best. Let's find out. Let me just quickly check. In option 4, we have the monthly situation. So that's 12 payments per year. I'll squeeze a little 12 in there, and I'll remind myself that's 12 payments per year for 10 years. That's 120 payments. So as I look at my calculation then, that's 1,000 times 1.01 to the power of 120 payments. I'll write it out just so you can see it as well. And my calculator, oops, sorry, couldn't see either thing. My calculator is giving me $3,300.39, which is comparatively the best of the 4 options. So as I look at this carefully, I can clearly see all 4 options laid out, and I can see that option 4 is the one that gives me the most money. Where it says prove it, I would honestly just show what you see here on my little post-it note. This is how you would prove it. You would just show your 4 calculations, you would show how many payments with the correct multiplier, and you would simply show the calculator value that gave you those comparative numbers. So hopefully you can kind of see that in the big picture, it does seem as though the best investment strategy is to take smaller payments multiple times a year compared to one big lump payment once a year. And that is good general advice. If they give you the option of breaking up your interest into smaller pieces, it is more advantageous to do that. Lots of smaller payments actually does add up to a bigger overall account value than one big payment per year. So that is worth noting, because you'll definitely see that situation come up. Make sure that this idea makes sense. Make sure that you have a sense of why we did what we did with the numbers. And once you have a good idea of what's going on, then you'll be ready to move on to question number 2.